Morning class, it's already 8 p.m.
Morning, Miss.
Good morning. Okay, so let's start today's. So yesterday we covered 6 types of sets, and today we will cover another 6 types of set. Um, Let me present my screen. Today is day 3, so we'll have just a moment. Okay, so as I mentioned, today we will cover the 6 more types of set that we have left. So we will get on track. But first, let's see, how are you doing? Are you guys sleepy? Are you hungry? Are you tired? It's early in the morning. How are you doing today? So I'll just go over the basic rules. Remember to turn on your cameras, to mute your mic unless you are to talk. Be on time, raise hand, be confident to share, listen, and please no eating. Ryan says he's tired. It's just 8 in the morning. You should be feeling energetic today, right? So, um, we'll start today's class with a short activity. By you will give an example or examples of a singleton cell. Remember, singleton cell comes from single, right? You will share this in the chat box. Give an example of a singleton set. Set. Singleton set. I don't know why I keep confusing it with cell, right? Maybe because I look at my cell phone every time. Who says Miss Diane thinks I cannot? It's okay. If you're not feeling well, it's okay. Okay, but we'll start with the activity whereby you'll give an example of singleton set. Anyone who wants to share an example of a singleton set? Remember, I mentioned yesterday I gave an example whereby if I had um, removing by mouth, says Ernest. Yes, but how would you put that in a set example, right? X is the mouth that we have in our body. We just have one mouth, right? So that's singleton. Another example could be
Miss,
what
the set of teeth.
but apart from that, I gave you the example from the nail polish, right? If I had only one nail with a nail polish, then that can be an example of a singleton set. Now, um, our x is the set of 2, 4, 6, 8, and y is the set of 1, 2, 4, and 6, equal or unequal sets.
Miss,
Yes, I want to hear everybody what everybody thinks about this one. But yes, Ernest,
listen,
what do you? Yes,
they are similar in the same amount of numbers.
they are similar in the same amount of numbers, but remember what we are talking about: equal or unequal. Equal means what equal means? Equal means that they have the same elements, right? Unequal means that they at least one element is different. So which one is this one?
Number one, Miss.
Number one, yes, but is it equal or an unequal set?
It is an unequal
Unequal,
set,
Miss.
Miss.
Unequal set. Very good, right? Because we see that we have one there and in set X, we don't have one. So it is an unequal set. But very good point, Ernest. We will cover this that you just mentioned in today's class. So very good observation. They have the same amount of elements. Now, number two, F F is the set of classmates whose first name starts with the letter F. Is that a null or a singleton set? If you have to go to the chat box and see your classmates there, that's okay. But is the set of classmates whose first name starts with the letter F a null or a singleton set? Do you have any classmates whose name starts with F? No, right? Krista says null, Gerald says null, and Ernest says null. Very good. We don't have a classmate whose name starts with the letter F, right? We just have one that his surname starts with the letter F, but hence we can say that this set is null. We don't have any elements, right? So basically this is just a little revision on what we covered yesterday, the six types of sets, which were, can anyone say one type of set that you remember? I have, let's say, four there. So you could have shared two more. We have equal, unequal, null, and singleton. Any two persons want to share two more sets that we covered yesterday?
Finite.
Finite, very good. And say finite. And
Infinite.
and
Infinite.
infinite is the set, very good, right? So we also covered finite and infinite. So finite is just the one that has an end, right? And infinite can have many elements that we cannot count. So that is basically what we covered yesterday. Now we will cover some more type of sets. So first we have the equivalent set. The equivalent set are two sets that have the same number of elements. Remember, Ernest said that the example that I just mentioned in number one, they had the same amount of elements, right? So this is a type of set that goes with that one, even though the elements are different. So two sets are equivalent when they have the same amount of elements, although the elements are not the same. We have an example. Set A is 1, 2, 3, and 4, right? And we have set B. Set B equals to A, B, C, D. We see that the two of them have four elements, right? They have the same amount of elements, but they are not the same, right? So this is what equivalent sets are. These are two sets that have an equal amount of elements, but the elements do not need to be the same, right? So this is represented with a little sign there. Some of them use the equal sign, but I didn't put the equal sign here because you will confuse with the equal. Use the equal sign, right? So this is different from the also. Remember, the equal set has the same elements. It does, but equal sets have the same elements, right? And this one has the same amount. Amount of thing is that the cardinal number is the same, right? This is what this is saying because we're talking about amount. So this has the same amount of elements, but the elements do not have to be the same, right? So this has the same amount of elements, but the elements do not have to be the same, right? Equivalent sets. Any of you have an example? Let's see if someone can give me an example of an equivalent set. Maybe just a set that has two elements. It doesn't have to be a big set. For instance, 1, 2, 3, and 4.
Yes.
And that, yes. And that could be
In a football game, Miss, two teams have 11 each.
very good, right? The two teams have 11, but they are not the same elements. You cannot have the same player in this side and on the other side and the two teams, right? So very good observation. That's a very good example of equivalences. They have the same amount of players, but they do not have the same players. Okay, so that is equivalent set. Now we have overlapping set. When you hear overlapping, we immediately think about this little image where two of them have something in common, right? So overlapping sets are basically um one element of set A is present in set B, so they have something in common. This is what this set is saying, that the two of them have something in common, so it overlaps. Um, it could be one element, two elements, three elements. It could be from one as of many layers. It could be one element or it could be all the elements could be overlapping, right? So two sets are seen to be overlapping if at least one element from set A is present in set B. And have an example. We have set A is the set of 2, 4, and 6, and set B is the set of 4, 8, and 10. We see that we have number 4, right? We have in the two examples, we have number 4. We have number 4 in set A and we have it in set B. Therefore, A and B are overlapping sets. And this is how it is represented in a diagram form, which I have at the bottom, right? The shaded is the one that is the overlapping. So um remember to please turn on your mics. Okay, thank you. Okay, so overlapping sets. What could be an example of an overlapping set? Maybe my name is Janelle, right? It has 8 letters. It starts with a G. Whose name in the class has a letter G present?
Gerald.
Gerard, right? So that could be, oh, and Gerard has the E2 and the L. So that will be 3 elements, right? That are the same. We have the G, the E, and the L, right? So that means that they are overlapping because they have 3 elements in common, right? So this is overlapping sets. They have at least one element in set A is present in set B also. So we move on to disjoint set. What is disjoint set? As you can see in the image, it is different from the image I presented before, right? These sets are disjoint if there is no common elements. So overlapping was when we had common elements, right? But disjoint is when we have no common elements, nothing in common. So we have an example. Set E is 1, 2, 3, and 4, and set B equals to 5, 6, 7, 8. We have no common element there, right? There is no element in set A that is also present in set B. So we see those are disjoint sets, and this is how it is represented in the circle forms. They are separated. They are not overlapping, but they are separated um, from each other. So, as I mentioned, do not confuse with overlapping. Overlapping has something in common. Overlapping, has something in common from set A and set B. Now, on this one, disjoint sets, they have nothing in common, absolutely nothing, right? So, what could be a disjoint set? Maybe my age along with Gerard's one. We have, it's not common, right? But I don't think so. So this is what the drawing said. The is talking about we do not have anything in common. Maybe that could also be your parents. Mirani's parents is not the same parent, my parents, or Gerald's parents, or Ernest's parents, or Pascual's parents. They are not the same. So those are disjoint sets. Okay. now we go to, so before moving on to the next type of sets, do you understand the three types of set that we have covered up to now? Do you have any questions, or do you want another example to better understand? You see, okay, they are understanding, but I hope Gerald is not talking. Gerald cannot talk for the rest of you, so Gerald is understanding, but how about the rest of you? Have 20 others in the class, so Ernest says he also understands, but I hope everybody is understanding, everybody is on track. So now we go to subset and superset, right? Subset and superset.
I understand it.
Okay. Okay. So we can move on to subset and superset. Okay. We have for two sets A and B, if every element in set A is present in set B, then A is a subset of set B, and it's represented like I have there. And B is the superset of set A. I will repeat that. For two sets A and B, if every element in set A is present in set B, then set A is a subset of set B, right? For example, A equals to 1, 2, 3, and B equals to 1, 2, 3, 4, 5, and 6. We know that the elements in set A are found in set B, but every element in set A, only not only one element, but every element in set A is found in set B, right? So when we realize that we can see that set A is a subset of set B, but B is the superset, right? So why? Let's look at this little image that I have in the back, way at the top. Set A, as you can see, if we have, let's say that we can include here 1, 2, 3, and then set B. Because set B is the bigger set, right? And because set A is a subset, we can see that B is the superset. Why? Because we extract those numbers in set A from set B, right? We can extract them because we can have 1, 2, 3, right? So what this is simply saying is that A will be the subset, but B will be called the superset. Okay? I will repeat. For two sets, A and B, if every element in set A is present in set B, then A is a subset of set B. And we have that little like C with a little bar representation of subset, right? And that's how it's written. A is a subset of B, and B is a superset of set A, right? Are you understanding this one? Do you want me to repeat?
Miss, I would like you to repeat it.
Okay, just a moment.
Yes, can you give us another example?
Okay, I will give another example. Let's say we have how many classes? Let's say we have, let me put it in this way. Just as I mentioned from my name and Gerald's name, right? My name has, let's see, if we put it, I will type it here. If we have, oh, it won't look that big. If we have set C equals to, let's say, Gerald, oh, that won't work. I will use, whose name? Let me see. Ryan. Ryan, and then we have B equals to another Ryan, right? That we have. Okay, in this example, we can see that all the in set B, I mean in set C, form part. I will make this even bigger just so you could see. Uh, just a moment. Write it in your notebook for you to understand. Also, write the two names, Ryan with R-Y-A-N and Ryan with R-A-Y-A-N. Okay. Okay. I have set C equals to Ryan and set D is also equal to Ryan, but they have different spelling. We could see that all the elements in set C form part of the set D, right? We can find all the elements in set C in set D. Am I correct? We are
Yes,
not
miss. Yes,
we are
miss.
not okay, we are not seeing only one element. We are seeing all the elements in that set, right? That are present in set D also. So because set C is the smallest, let's see, let's put it like that, is a small portion of set B, right? Because set C is a small portion of set B, we can say that it is a subset because yes, very good, we can find all the elements of set C in set D. That is a subset. So now that we know it's a subset, that set C is a subset, we just take the other set, which is D, and we call it the superset, right? Because we get from this D, we get to see which elements are there. And as you notice, the almost every time the other element, which is the other set, which is the superset, is bigger than the subset, right? So are you getting it now, or do I need to repeat again? Reset, are you getting it now, or do I need to repeat? Don't be
Hablé
shy
con
to
su
say
papá.
so.
Yo
I
hablé con
can
su
repeat
papá.
it again.
Yo hablé con su papá todo. Hablé con la mamá, hablé con el papá.
Well, if you have time, Miss, please.
Yo nunca vi esos de chamaco.
Okay,
Yo no entendí
because
nada. Y
as I
luego que quieren
mentioned,
decir, no,
the subset is just, you have to look at the
le
two
gusta saben
sets,
porque no
right?
digo,
You
y no
have
me
to look
manda
at the
ahora.
two sets.
Y
Let's see.
el papá
We
dice que
can
el papá
see
dice que
that
no me manda.
set C has 4 elements and set D has 5 elements. So those do not automatically, they do not have the same amount of elements, right? Right? In order for them to be the same, we will also need another A in set C, but we do not have that, so we just have this one. So because all the elements in set C, which are R, Y, E, and N, are found in this set D, which is a bigger set, we say that
Si
C
entras
is the
del bedroom,
subset. Now, if I had the opposite, right? If I had D equals to C, I
hablé
mean
con la
D
mamá
equals to
ayer y le digo a la
Ryan
mamá,
with
le digo,
just one A,
Phil.
and C
Y la
was
mamá,
Ryan with
estás
with
escuchando.
another
Eso dice.
with the two E's, then D was to be the subset. But because I had it labeled there, as I
Está haciendo bien
mentioned, you
conmigo.
have to see the
Lleva 2
two
semanas que no
sets.
entro.
You will not only see one set and say this is automatically the subset of the next one. No. You need to look at the two of them and be sure that at least one of them
Era mangar a
has
su mamá para que no diga más.
all its elements are present in the other set, right? Since all the elements in set C are present in set D, those are called subsets, right? C is the subset of D since all its elements are present in set D. Now, because of that, we call D this superset, right? Because C is a subset of D, we call D the superset, right? So this
No,
is
yes, Miss, I don't got it. Thank you.
okay, okay, good. So this is subset and superset, right? Just remember to find the subset. If C is the subset of D, then that means that D is the superset. In any example, if we had two sets, let's say E and F, if E is the subset of F, or we can see that F is the superset in any example, right? Now we have the universal set. A universal set is the collection of all elements in regards to a particular subject, right? All elements in regards to a particular subject, and it is denoted by the letter U. It is denoted by the letter U. And we have an example here. Let U equal to the list of all road transport vehicles, right? We have a set of cars is a subset for the universal set. The set of cycles, the set. Why are they subsets? Because the universal set is talking about everything in general. It's not talking just about one road transport. It's talking about all the road transport, right? So because it's talking about all of them, we can categorize them, right? We can have subsets of that, because if we have the set of cars, right? The set of cars is just, let's put it, C is the set of cars, and U is the list of all road transport vehicles. Of course, C would be a subset of U, because we will find that in U, right? We will find that in that set of all road transport vehicles, because all road transport vehicles are talking about, let's say, the cars, the trains, the cycles, everything, right? All road transport vehicles. We could be talking about motorcycles, those will be subsets. So, but U is all, is everything in general, right? And as you can see in the diagram, it is represented with a little U. And if you tomorrow we'll be covering a little bit about Venn diagrams, and this is how it will look with a little U at the top. Are we clear on the universal set? As I mentioned, it's just a collection of all the elements in regards to a particular subject. All the elements. It could be talking about many things. Is this clear, or do I have to repeat? Clear, miss? Okay, I will give another example though. For example, all the vegetables in your kitchen, right? We have many vegetables, right? We have many vegetables. But because U is the set of all the vegetables, we include them together. So it we call it the U because we are talking about it. However, we could subdivide it into subsets, right? Because we can find the subsets of that, we also can know that it is U, it is the universal set, because it is everything. It entails everything, right? So it is a collection of all the elements in regards to a particular subject. Now, the power set. The power set is the set of all subsets that a set could contain, right? For example, we have set A equals to 1, 2, 3. The subsets, the power set of A equals to, we have an, can someone tell me what this first one is? We covered that last class. Is the representation for what? The first one, very first one. A is, and then we have the curly brackets, and we have something there. What does that represent? Come on, have you forgotten? We just covered that yesterday. That is the symbol used for. Anyone remembers? Anyone remember? No. Yesterday we weren't talking about commutative property. That was last week. This week, what were we talking about? Remember the types of sets that we covered yesterday? Which one that I mentioned or that I presented had this little symbol? Null. Very good. Very, very good. It's a null set. So subsets, we will not go in depth with the subset, but these are the subsets of set A, right? We have the null set, we have 1, 2, 3, 1 and 2, 2 and 3, 1, 3, and 1, 2, and 3. Right? So the power set is all the subsets together. Because we can see that 1 is a subset, 2 is a subset, 3 is a subset, right? But they are not asking you for one subset or two subsets. So the power set is all the subsets, right? So it's basically straightforward. All the subset that a set contains is a power set. All the subsets together, right? That is basically the power set. It's not talking about a subset, one subset individually. It's talking about all the subsets. That is a power set. Is this clear? Yes, I only hear Gerard.
Yes, miss.
Okay, I hope so. Lizette, did you get this one?
Yes, miss. This one is.
Okay. Now, this were the 6 types of set for today. Now, true or false. Some of these questions are found in your assignment 1, number 5. So please take note. I don't think it's all of them. It's just like 2 or 3 of them, right? So write it in your notebook and record your responses. We have set A is composed of 3, 5, and 7, and set B equals to 5, 3, and 7 are equivalent sets. True or false? Are those equivalent sets?
Yes, miss.
Remember? Okay. Who's it? Why do you say no?
Miss, I say yes because it have the same numbers, but just because it is mixed.
Okay. Gerald, why would you say no?
Because of the order.
Okay. Remember, this is a tricky question. Why? Why? Because equivalent set have the same amount of elements. But remember, yesterday we covered equal sets. Equal sets have the same elements, but maybe it doesn't have the same order, right? We can see that these ones have the same elements, but they are not in the same order. First we have 3, 5, and 7, and we have 5, 3, and 7. So if we are to categorize them, they are equal sets. They are not equivalent sets, right? Why? Because they have the same elements. If if let's say if A was 3, 5, and 7, and B was A, B, and C, that will be an equivalent set. Why? Because they have the same amount of elements, and um, elements are not the same, right? When they have the same elements, those are equal sets. So this question is true or false?
Miss, as how you explain it, it's false.
It's false. Very good. It's false because we have the same elements. If we didn't have the same elements, those will be equivalent. But because we have the same elements, we cannot say it is equivalent. Now, number 2, A equals to FIAS and B equals to ANFHS. Are those disjoint sets? True or false?
True, miss. They are disjoint.
Remember what are disjoint? Disjoint? Say all. Okay, because at least one element is similar or is common in the two of them, right? We have E in set E and we have in set B. We also have an E, right? So because we have one element in common, those are not disjoint sets. So this is false. Those are overlapping sets. Remember, disjoint and is when they have nothing in common. Nothing in common. But overlapping is when they have at least one in common. Now,
Okay, Miss, sorry, I get confused.
okay, no problem. C is the prime numbers greater than 2 and D equals to all even that our prime numbers are overlapping sets. The set C, which is the prime numbers greater than greater than 2, and D is all even numbers that are prime numbers are overlapping sets. True or false? C says prime numbers greater than 2. And this is all even numbers that are prime. Are those overlapping sets? Anyone wants to share if those are overlapping sets? What do you think? True or false? Just give me an answer, true or false, and we will discuss why is it true and why is it false. So are set C and D overlapping sets? True or false? Emerson, Emerson says true. Who else agrees? Who disagrees?
True.
True. Zaire says true. Ryan says true. Ryan says false. Okay, we'll take a look. Prime numbers greater than 2. Because it says greater than 2, we do not include 2, right? Right? And prime numbers are only divisible by 1 and itself, right? So, taking that in mind and looking at set D, all even that are prime numbers, because in set E we cannot include 2 because it says greater than 2. It doesn't say it's greater or equal, right? It says greater than 2. We start counting from 3. 3, 5, 7, and so on, the list of prime numbers, right? And this is all even that are prime numbers are all even that are prime numbers. But the only even prime number is 2, right? Am I correct? Right? So do they have something in common? Do they have something in common? Do they have an element in common? No, right? Because we cannot include 2. So because they have nothing in common, we say those are not overlapping sets. These are disjoint. So this one is false, right? These are disjoint. Please write the correct one at, to the side because your activity does not include in true and false, but I make it in a true or false. Okay. So we have number 4. X equals to 1, 2, 3 is a subset of y equals to 1, 3, and 5. True or false? X is a subset of y. True or false? Ryan says false.
False, Miss.
False, right? It's false because the elements, not all the elements of set X are in set Y. So this is false. Now P, set P and Q are disjoint sets. We have 10, 20, 30, and 40, and 15, 25, 35, and 45. Are these disjointed? True. Very good. They are. Okay, very good. So now let's see what we have here. So this one, P we have SUN with son, and Q we have STER. Is this joint, disjoint, or overlapping? Remember, are you sure? See the elements clearly. Give it a next try. Are those disjoint or overlapping?
Overlapping Miss.
Overlapping, right? Because they have, yes, they have at least one element in common, which is S, right? Now, number two, we have A is the natural numbers between 35 and 60, and B is the natural numbers between 50 and 80. Are those disjoint or overlapping? Set A is between 35 and 60, and set B is 50 and 80. So are those disjoint or overlapping? Overlapping. Very good. These are overlapping also because when we reach um to let's say 35 to 60, when we reach to 50, we have 50 on the next set, right? We have 50 to 60. So these are overlapping sets. Now, oh, this is just choose the correct type of set. Equal and equivalent. Is it A and B equal or equivalent? Just to remind you about the set that we covered yesterday and the one we covered today. Are set A and B equal or equivalent? Recept, could you answer this one? Because I know you got this one a little.
Equivalent, Miss.
Anyone else wants to share what they think? Is this equal or equivalent? This is equivalent. Why? Remember, equal sets have the same elements. Maybe not in the same order, but they have the same elements. And equivalent has the same amount of elements. If we count and say, here we have 1, 2, 3, 4, 5 elements, and in set B we have 5 elements too. So this is an equivalent set. Now, number 2, set C and set D are equal or equivalent. We have set C is 2, 4, 6, 8, and 10. And then we have D, which are even natural numbers less than 12.
Equal.
Very good. Those are equal sets, right? Those are equal sets. Okay, so Josh Hartley, what were the 6 types of sets that we covered today?
Equivalent, overlapping, disjoint, subset and superset, universal.
Very good. Very good. This were Gerald also put it in the chat box. We covered equivalent sets, overlapping set, disjoint set. We covered also the subset and the superset, the universal set, and the power set. Those were the 6 that we covered today. Now give a real life example of overlapping sets. Remember, I give you an example with my name and Gerald's name. Just have 1 more minute. Anyone who wants to share that one? Because we just have 1 more minute. Just one person to share a real life example of overlapping set. Xaris is my sleepers along with what? Remember, overlapping set have to be 2 sets. Maybe if you have how could I see? maybe if you have, let's say, three different types of slippers, and let's say Lisette has four types of slippers, but she has one that is similar to your one that is common, right? You have one in common, then those are overlapping sets. Remember, overlapping sets have at least one element in common, at least one thing is common in the two of the sets given. So that was all for today with the sets, the six types of sets that we covered. So overall, we covered 12 types of sets from yesterday and today, right? So yeah, it's time. That is all for today. That was the end of our class. So I will see you guys tomorrow for a little bit more about sets.
Miss, I won't be
Okay.
able to get in the class tomorrow because there will be no electricity.
Oh
Same.
Same.
yes, that's true. I think many of you will not be able to get to class. Okay, if we can do the class tomorrow, then maybe I just record some key information and I will send you guys. But as I mentioned, I will be updating this PowerPoint tonight so that you can access it too. And we also have the content in the Google Classroom, right? So that is it. And hopefully tomorrow some of you can be in class. If not, well, ni modos. Okay? So bye guys.
Bye, Miss Jeanette. Bye, Miss Christie.
Bye.
I'm Christy by
Bye.
Bye, guys.
Bye.
Bye, Miss Christie. Bye, Miss Catzim.
Bye, Valeria.
Bye, Miss Ben. Bye, Miss Christine. Have a wonderful day.
Thank you, Gerald. Bye.
Thank you.
Bye, Miss Ben. Bye,
Bye,
Miss.
Miss.
Bye.
Bye.
Bye, Miss Ginali. Bye, Miss Katsi. Miss Christy, sorry.
Goodbye.
Bye, Lizette.
Goodbye.
Bye, Kami.
Wait, so if I think many of the students won't have electricity tomorrow. Yes, I forgot about that.
Will you be having electricity tomorrow?
Yes, I will.
Okay, I will be having as well. Most of the students won't be having, but I would suggest to still have the class
Yes.
and then the recording, even if it's just maybe like 10 of them that would join. But I would suggest still have the class so that then they can view the recording because they will have Friday as well to do the assignment and have the time to do that. Okay,
Okay, ma'am.
for this session right now, let me tell you what I observed. Um, I think that you would have to review maybe a quick revision on subset and superset.
Yeah, I think that was
Don't think that everybody grasped that.
last
And then as well the power set.
hours.
I would suggest it would be maybe like your introductory activity for tomorrow. But when you ask the students for subset, it would be good if you would give them a set and then you ask them to list you the subsets
Okay.
so that they can understand where the subsets come from. And then using that same example, you can tell them that all of these subsets come from the superset, which is the set that you had given them in the beginning. So then when you go to power set, then you can tell them, okay, all the subsets that we listed that makes up the power set.
Okay.
So then you are
So that will be
tackling,
together just for them to not get
yeah,
confused.
just to have the clarification after today's
Okay.
class. In regards, okay, I saw that you use an example about Ryan and Ryan. It is always good for you to have extra examples. Even if you use them or you don't use them, even if it's on your slides, you can always, if you see that they understood and you don't need the other slides, you can just skip it. You don't have to show everything on your slides. But it's
Okay.
always good to be prepared in the case of anything happening. In the case of the example that you used, um, it was a good example, but the way that you set it up did not reflect how the students should set up their examples. So I said that you put Ryan and you typed out the name Ryan. When you want to set up an example and you want students to see how a set is set up, you have to write capital R, comma, capital Y, comma,
Okay.
capital A, comma,
I
capital
figured
N.
that.
So you don't want the students to be confused, especially if you give them, like next week you might give them an example that has letters. You don't want them to be writing all the letters right beside each other, right?
Okay.
um so then that would be, and then when you use the other Ryan, Ryan, if you write out the capital R, comma, then the double A is not used. You will only include one A, so you don't repeat the
Okay.
elements. All right, so that was a good example. That was the only thing that I noticed, that you would have to be careful if you want to use another name as an example in another session. Um,
Okay.
so then that was all that I observed. But apart from that, I see the students are participating more. They're letting you know if they don't understand,
Don't
which is a good
understand.
thing. Um, so apart from that, then that would be all. Do you have any questions?
No, miss. That's good.
Okay.
Okay.
Um, were you able to provide feedback to the first activity?
Yeah, I did so
Okay.
last night.
Okay. So then that will be it. Then you are finished with the week 6. Um, I did call some parents yesterday in regards to missing assessments and then failing grades. Um, I spoke to Eligio's father and I spoke to Tisha's father. They should be submitting work, but I'm not sure because I didn't see anything last night when I checked. No, well, not last night. Yesterday afternoon, I didn't see that they had sent. So, um,
I see some of them sent, but I don't think it was this assignment they sent from week 2, week 5. Some of them sent from those, I think.
so then those ones, then I will be checking those ones. So you don't have to worry about those ones. But just like maybe on a weekly basis, just go back and check if anybody submitted week 6, especially those that have it missing.
Okay.
But if week 9 comes and they haven't submitted, they have to give all of those students a 0, right?
Okay.
So then that will be it, Miss
Thank you.
Catzim.
Thank you.